9 subject matter experts assessed commercial off-the-shelf, body-worn cameras with automatic activation capabilities, specifically unholstering a firearm and engaging vehicle emergency lights or sirens. Products were assessed against manufacturer-provided specifications and while performing simulated operational activities at New York State Department of Homeland Security and Emergency Services State Preparedness Training Center, located in Oriskany, New York, from September 19th through September 22nd, 2022. Body-worn cameras are used to record interactions with other responders and the public while on duty. These cameras may be used by all responder disciplines to ensure transparency, deter aggressive behavior, preserve evidence, monitor personnel, document interactions, support the accuracy of written reports, provide a training tool, and aid in improving standard operating procedure. During this assessment, 4 body-worn cameras were evaluated, as well as associated automatic activation sensors. Evaluators assessed each product based on their experiences during a familiarization session that included a discussion of manufacturer-provided features, specifications, and uses of the product, and 3 operational scenarios. During the emergency light and proximity automatic activation of body camera scenario, evaluator teams donned a body-worn camera. A vehicle equipped with emergency lights and the respective demonstration kit for auto activation trigger being tested was parked outside of the shoot house. With their body-worn camera turned on, but not yet recording, evaluators were notified of a disabled vehicle. An evaluator then turned on their emergency lights and sensor demonstration kit, drove to the scene, unbuckled their seatbelt, stepped out of the vehicle, and conducted a field interview with the occupant of the vehicle. A second evaluator arrived on scene to test if their cameras automatically activate by the proximity to the first evaluator's cameras. Once the scripted dialogue was complete, the officers returned to their cruisers and stopped the body-worn camera. After the scenario was complete, evaluators reviewed the camera footage according to the vendor's specifications, either using a mobile application or on the camera screen. During the unholstering firearm automatic activation and visual acuity scenario, evaluators donned a body-worn camera and configured a holster with the activation sensor. Some evaluators donned gloves as well. Using a non-functional training firearm and the appropriate holster with the activation sensor mounted, evaluators ensured their cameras were powered on, drew their firearm with the intent of activating the camera to start recording. Evaluators said aloud what the poster depicts for later comparison to video footage. Functionality such as privacy controls, such as mute buttons, by audibly announcing their intent to activate them, activating them, counting out loud to 5, then disabling them, were also tested. During the mock room clearing scenario, evaluators began recording manually, and then proceeded through a series of rooms, clearing the area of a potential threat. Rooms had a varying degree of lighting and included silhouette targets, color charts, and visual acuity signage. The evaluators employed standard law enforcement room clearing procedures and described the items encountered aloud. After clearing all of the rooms, evaluators stopped the camera and tagged the video as to the nature and type of incident when possible. The subject matter expert evaluators assessed 4 body-worn cameras. These were assessed against a total of 30 evaluation criteria within 5 of the SAVER categories: capability at 40%, deployability at 20%, usability at 20%, maintainability at 15%, and affordability at 5%. Axon Enterprises Body 3. The Axon Enterprises Body 3 received an overall score of 4.1. Evaluators found the body camera to capture crisp image quality with impressive motion blur mitigation and image stabilization. One disadvantage identified was an operating temperature range of -4 to 122 degrees may not be sufficient for all climates in the United States, as some regions may experience temperatures below -4 degrees Fahrenheit during operations. Utility Body Worn, currently known as EOS. Utility Body Worn. The Utility Body Worn received an overall score of 3.7. Evaluators found the camera focused easily and quickly, even when moving quickly or running, and noticed the image quality adjusted from motion once stopping. They had no issue connecting the camera, which is in the form factor of a cell phone, and paired with the wrist-mounted Bluetooth controller. They stated the phone's interface was user-friendly for field tagging. However, there were drawbacks with the use of the wrist-mounted Bluetooth controller, as it turned into a two-hand operation. Additionally, the center mass mounting of the camera is not optimal, particularly in driving scenarios, where the view can be obstructed by seatbelts and, for female officers, which could impact the angle of recording. Motorola Solutions V300. The Motorola V300 received an overall score of 3.6. The device features a configurable, always-on, record-after-the-fact buffer that recorded continuously without the need of a manual or automatic camera activation, as well as an adjustable pre-event buffer of up to 120 seconds. Evaluators expressed concerns regarding image quality as the device did not offer blur mitigation, which affected overall clarity, and lacked the ability to adjust to changing light conditions. Motorola Solutions Motorola VB400. The Motorola VB400 received an overall score of 3.3. This camera has 5 software configurable switches, as well as an adjustable pre-event buffer of up to 120 seconds. This device can be outfitted with numerous mounting options including magnetic, MOLLE, quick release, harness and alligator clip, and has multiple charging methods. Inability to field tag video without required software, as well as the lack of blur mitigation and image stabilization, were a few disadvantages. The subject matter expert evaluators also assessed 3 holster sensors which activate the camera when the sidearm is drawn. These were assessed against a total of 9 evaluation criteria within 3 saver categories: capability at 50%, usability at 25%, and deployability at 25%. Axon Enterprises Signal Sidearm. The Axon Signal Sidearm, which was paired with the Axon Body 3 BWC, received an overall score of 3.8. The sensor's small size did not impact operations, giving it a high score in the usability and deployability categories. However, the sensor did not consistently activate unless the weapon was fully seated within the holster. Motorola Solutions Yardarm Holster Aware. The Motorola Yardarm Holster Aware, which was paired with the Motorola V300 BWC, received an overall score of 3.7. This sensor activates quickly and has an expected battery life of 3 weeks. However, the battery takes an estimated 8 hours to charge. Evaluators expressed concerns that the sensor affixes to the holster with a permanent adhesive, which limits the ability of reassignment and risks holster damage. Utility Associates Smart Holster Sensor. The Utility Smart Holster Sensor, which was paired with the Utility Body Worn, received an overall score of 3.6. This sensor's small size did not impact operations. Evaluators experienced pairing issues between the sensor and camera, and disliked that the sensor charged via a micro USB. Axon, Motorola, and Utility offer sensors hardwired into a vehicle which automatically activate a BWC when engaging the emergency lights and sirens. Evaluators were in favor of this activation method as it seamlessly integrates with their policing operations. Classroom demonstration models were brought to the assessment to showcase capabilities and characteristics of vehicle sensors. Due to the inability to hardwire these sensors into the test vehicles at the assessment, solely qualitative feedback will be summarized. Axon. The Axon Signal Vehicle Demonstration Sensor was paired with the Axon Body 3. Generally, evaluators found the automatic activation to function as expected. There were 2 instances where it took up to 30 seconds for an activation to occur. This was attributed to operator error. Additionally, the distance for activation, estimated range of 15 to 30 feet, and in one scenario more than 50 feet, was found to be acceptable for its intended purpose. 2 evaluators noted that they'd prefer a continual sensor activation when on scene, as the current model is appropriate for initial law enforcement officers arriving, but it does not account for assist officers that may arrive later on scene. Ideally, everyone involved in a response would have their cameras automatically activated if another officer's was on. There were 2 instances when one camera did not activate on proximity. The camera was powered off, then powered back on, which seemed to address the issue. The muting feature was successfully assessed during this scenario as well. Motorola Solutions M500 in-car video system. The Motorola Solutions M500 in-car video system demonstration sensor was paired with the Motorola Solutions V300 to assess the automatic activation and proximity sensors. Several evaluators noted issues with maintaining the pairing between the demo sensor and the cameras, which led to several failed activation attempts during the emergency light portion of the scenario. When the cameras were in closer proximity to the demo sensor, less than 30 feet away, the number of automatic activations increased. This was attributed to the Bluetooth connection being used for pairing the demo sensor to the cameras. The signal between the cameras was strong, resulting in consistent successful proximity activations. Utility Vehicle Sensor. The Utility Vehicle Sensor demonstration unit was paired with a utility body-worn to assess the automatic activation and proximity sensors. The demo sensor was paired with a specific camera, so when turning on, only one camera was automatically activated, even if there was more than one camera present. Automatic activation functioned as expected. Evaluators noted the importance of having the cameras activate their fellow officers on scene, which is not a feature of utility body-worn. This assessment was made possible by the National Urban Security Technology Laboratory's System Assessment and Validation for Emergency Responders program, known as SAVER, that provides information on commercially available technology and equipment that first responder agencies can use to make informed operational and procurement decisions. To learn more about the capability, deployability, usability, maintainability, and affordability of these products, access the full body-worn camera with automatic activation assessment report. For more information on the SAVER program and for access to more than 1,000 first responder-focused reports, visit the SAVER document library. NuSteel thanks the assessment evaluators for their valuable time and expertise, specifically the Cabarrus County Sheriff's Office, Fairfax County Police Department, Gwinnett County Police Department, Philadelphia Police Department, Stanislaus County Sheriff's Department, Tampa Police Department, Troy Police Department, Tulsa Police Department, and Vail Police Department. Their insights and recommendations will assist responder agencies making procurement decisions. Appreciation is also extended to the New York State Department of Homeland Security and Emergency Services State Preparedness Training Center for hosting the event.